Yeah, so last week at the latter part, we discussed about the evolution of computer, and we discussed that the idea of the computer, or like idea of computing, was there like 5,000 years back, and the recognizable device was the abacus on those days, where they use it for the calculation. Even today, Chinese people, Japanese people, they still use the abacus to do the calculation. So they have that technique of doing that in a very fast manner. And as the milestones, we talked about in 1642, the adding machine, which is invented by the Blaise Pascal, right? And in 1674, it's the one who improved the Pascal's machine, which is the adding machine, which is Gottfried Wilhelm, where he has given the ability of multiplication and division into it, right? And at the same time, the Joseph Jacquard, the French scientist who invented the punch card system for looming, right, which is related to the fabric works, right? Right, so he has invented the punch cards to have the patterns on these particular fabrics. So later it was used to indicate the ones and zeros for computing, for the computers. And then of course the credit goes to the Joseph Jacquard as the person who has invented the punch card system. So then the one of the recognizable individual, the Charles Babbage, who we are like named as the father of the computer, has introduced the concept, which is input, process, and output, the concept. And he said like there can be a particular device which can have this kind of abilities. So later it was given, or it was embedded, or it was the base of every computer even today, the inputs, processing, and the output. So because of that reason, Charles Babbage is given the name, or like given the tagline as the father of the computer, right? And Lady Ada Augusta, actually the Madame Ada Augusta was recognized as the first programmer, where she wrote the programs for the analytical engine, which is invented by the Charles Babbage. And in 1944, the milestone was the Howard Aiken with his particular team in the Harvard University. They built up this Mark I, which is named as automatic sequence control calculator. And like it was the recognizable device which is working as a computer on those days in 1944. So those being, it was given the name as Mark I, right? So yeah, so those are few milestones. Like it's kind of a pre-mechanical era that they are talking about. Like I'm sorry, not the pre-mechanical era. They are talking about the mechanical era. So then after, with the invention of the this particular vacuum tubes, the computer has huge jumps or huge loops to have their evolution on the timeline, right? So the first generation, as we discuss, is based on the vacuum tubes, right? Let me take you the photographs, or like the turned ones. Here we are having this in the other way around. Hold on a second. Yeah. So the first generation, the technology was vacuum tubes, and inputs and output are given by the punch cards. The processing happens inside the computer. So the software they use, like the machine language, which we say like ones and zeros, and assembly language. You are going to learn about the assembly language in the grade 11 in the first lesson. And the stored program concept, right? So stored program concept is the concept which we are going to talk like with the name of von Neumann architecture in the next lesson, right? So then you get to know what is the stored program concept. So for the moment, it's better you remember those are the softwares that the first generation computers were using. And the characteristics I told you, it's better you remember the characteristics properly in the first generation. So with the time frame, with the time being, from generation to generation, these qualities are being improved. It is getting better more and more, right? So the characteristics of the first generation, we discussed that it generates a huge heat because of the vacuum tubes and all these electrical components. And it is slow in processing because we are talking about the very first era of the computer. And it is large in size. And I showed you some pictures as well as some video, as I remember. It was big as one big classroom or one big hall, like in your school, right? And definitely it's not portable since it is a building. And consumes a lot of electricity and was very expensive to build, right? There were many components that they have to spend on. So it was built for some specific reason and for specific tasks, majorly regarding these world wars. They were inventing these kind of computers where they have to do a lot of processing, which was very slow to do from a mankind, right? And the systems they invented, they have given some nice names like ENIAC, EDVAC, EDSAC, UNIVAC, and all these things. We saw about the ENIAC, right? The documentary that we watched was about the ENIAC. And the second generation happens with the transistors. So transistor is comparatively very small to the vacuum tubes. And the inputs and outputs were generated in the tapes and the floppy disk as the secondary storages. And the software they were using, they were beginning to use high-level programming languages. And again, you are going to learn about the programming languages in the grade 11 in the first lesson. It is the programming that we are doing nowadays for the grade 11s. And there was, and still there are, a language called assembly language that is being used as well. And as I told you, the characteristics are getting better. They are smaller in size compared to the first generation, less heat generation, low power consumption, comparatively faster, and still it is expensive, but not as expensive as the first generation. And the system, it's better you remember, right? Only 4 things: Honeywell 400, IBM 7030, CDC 1604, UNIVAC LARC. It's a extension of UNIVAC, right? And people in the examination, Sanisha, I'll come to that. In the examination, they are not generally asking about the name of the systems, but we never know, right? So it's better you keep the track of it. A Sanushi portable in the sense, Buddha, like if you take a mobile phone, it's a portable thing, right? We can take it anywhere, here and there, right? If you take a laptop, it's a portable thing. If you take a desktop, it is not a portable one. It's a standalone, or like it has to be used in a one particular place. That's what they mean by portable, right? So definitely the first generation computers are not portable in any way, right? Because if you need to make a portable one, you have to move the building, right? So anyway, it is not portable, right? That is what they are talking about, the portability. Right, okay. So now when it comes to the third and fourth generations, third generation technology is integrated circuits. And it is, they were using high capacity disk for the storage kind of things, and keyboard and mouse were introduced. It's a very important one. The keyboard and mouse that we are using today were invented on that era, right? So it's a third generation, right? Not very far away from us, like it's 1964. Like how many, like 60 years back? Yeah, some kind, right? So like then the softwares, it is the era where they found these operating systems, right? So far, they haven't any operating system in the first and second generations. They were just directly interacting with the computer like a Juki machine, like any other machine. But starting from the third generation, they had the operating system, right? It was very primitive. Like they have an operating system like MS-DOS kind of things, right? But still, it was a very important thing for the computer scientists to have an operating system, because it helps them to interact with the hardware parts without interacting them directly, right? We have to cut it with the involvement of us, right? So having an operating system means like we are not directly involved with the scissor to cut the paper. We are just involved with the operating system, and operating system is involved with the scissor to cut the paper, right? So we generally say operating system is creating a virtual machine for us, right? A virtual environment for us. So we are not interacting with the hardwares directly. Instead of, we are interacting with the operating system, and operating system will interact with the hardware of the system on behalf of us, right? You will learn about these things in the 5th lesson. We are going to talk about it in a very detailed manner. And they develop programming languages, high-level languages, and they use that for the coding, like Pascal, like Python, like Java, C++ kind of things. Those are called the high-level languages. Characteristics, as I told you, like it's getting smaller, having less heat generation, being fast, right? And cost is reducing. Still, it is expensive, but the cost is reducing, right? And lower power consumptions, right? And the systems are given, and we looked into the CDC 6600, as I remember last time. Did we watch CDC 6600 video, people? Or did we skip it and jump to the Apple computer, the introduction of the Apple? I remember we watched the Apple introduction, the very first Apple computer. And I really don't remember we were watching CDC 6600. Did I show you something which is in the museum? Some lady is explaining about it. Did we?
Yes, sir.
We did or we didn't?
So we watched it.
We watched it, right? Okay, right. All right. Okay, and the 4th generation, it is the starting point of the computers that we are using today, right? So the technology. Yeah, Rizwan, we are going to watch the 5th generation today, right? And the LSIC and these the very large scale integration and the large scale integration are the technologies, right? And microprocessor is one of the results of those. And they were creating these palm tops, high capacity disks, floppy disks, CDs, DVDs, and Blu-rays. Blu-rays actually come later. So they were starting off creating the optical disc. And the concept called personal computer, like the computers that we were using today, is given in the 4th generation, right? So until the 4th generation, no one will be able to have a computer at their house or their place. It was just an expensive thing, which was built for specific tasks. But like from after 1975, they were given the chance, or like they were given the ability to the general public to have their own computer at their home, right? So where it built the concept called personal computing. as well as the faster computer networks, right? And operating systems were having graphical user interfaces. Like graphical user interface is an interface something like this, right? Which is involved with a lot of graphics, right? And that is how the fourth generation went, right? And if you think about a computer like we are using today, those are the characteristics of the fourth generation as well, right? So very small in size, portable, upgradable, and it's not that expensive, right? According to the requirement, the price will be vary from computer to computer, but it is affordable, not that expensive, right? And the power consumption, heat generation, they are at the very minimal stage, right? The fast, the speed, I really don't need to talk about it, right? You know how speed a computer in nowadays. And yeah, we discussed about these four last week, and we are about to talk about the fifth generation. Yes, so before we jumped into the fifth generation, do we have any questions in the room? Like, if you got any question, it's time for you to take it to the room, or we can continue. Okay, all right, so let's continue. So it's a fifth generation that we have to learn today. It's not that big, like when it comes to the explanations. And I think you have taken these things down paper, right? And I will forward the things again into the WhatsApp group since there are new people in the class. So the fifth generation is like 1989, from 1989 up to today, right? So it will continue, right? And I wonder whether they will have a sixth generation, right? So like in the fifth generation, the technology is ULSI, ultra large scale integration. So with the help of ultra large scale integration, they were building up like the concepts called artificial intelligence, right? And we are dealing with a very high capacity disks and optical disk, as well as internet is here, right? And the operating system with GUI, and it is a normal thing from the fourth generation, and internet and multimedia applications are there. Some artificial intelligence applications are here, like voice recognition, face recognition, right? Fingerprint recognition, right? Those kind of things. And even handwriting recognitions. So there are many AI technologies are here, right? So if you think about the characteristics, it is portable, it is less expensive. We can't say it is inexpensive. It is less expensive, a smaller in size, and the reliability and efficiency is to the most, right? So it is a sector which improves day by day. So like for the moment, we are having these kinds of devices to make things easy in our life, right? So I have asked you to write these three things, these three tables in your book. So I will forward these things to you all. Yeah, Senilka, right? Senilka, it is reliability means whether we can trust it or not. Like අපි කියනවා විශ්වාසවන්ත භාවය කියලා, right? So like we can depend on this device now, right? And it will process things for us. It will do the things in a correct way, right? So that is what we call reliability, right? So like when it comes to the general terms, like a reliable person, the most reliable people that you can have is your parents, likewise, right? So likewise, it's talking about the trust, right? Okay, so with that, I think we have came to an end of the first lesson, right? So there are some activities, and as well as people, yeah, I will inform you. I have to go through my LMS and see whether you got a particular test for the unit 1. Hold on a second. So if so, you have to get ready on next week to do a small examination. It's not a very hard and fast one, right? Take it lightly and go through the stuff that we have done. Newcomers, don't worry about it. You can try that, right? Since we have come to an end of the first lesson. Yeah, I'm planning to have that thing. So just wait, I have to check it out whether it is ready or not, right? If it is ready, then we can go for it. Yeah, I'll check it and tell you meanwhile, right, whether we are going to have a one or not. Or else, let's do it like this. Since there are new people, you need some time to write down the notes and go through it, Nick. So I'm not going to keep it by next week. I'm planning to have it by week after, but anyway, I'm going to confirm you whether you are going to have a one from this lesson or like whether you are going to have like after the next lesson as well, right? Like together, both first and two, right? So let me go through it and tell you. So yeah, we can jump into this now, fundamental of computer systems. So yeah, before I move into it, I'll show you how to refer the lessons that we have done since there are new people in the room. So you have to visit the website starlabs.lk, right? starlabs.lk. This is the website's name, and I'll type it to you in the chat as well. All right, it's www.starlabs.lk. And in the website, you can go for the lesson recording and Starlabs recording. And in this page, you have to choose this grade 10 English medium tile, right? So once you click that, you will be getting a particular player like this, right? So usually the very latest lesson will be there for you to play. And if you want to refer the previous lessons, you can go with this particular icon, which we call the hamburger icon. Click on it and go for the very first one. Like the oldest one will be the last, right? So here you can refer it with the date as we have done the lesson. So there are 6 lessons so far. So you can go through the newcomers, you can go through these things anywhere, anytime you want, right? And get refresh about what we have done. Okay, so that is how we are going to refer the things. These are YouTube videos, people. So I'm stacking these things over here so it will be easier for you to refer. If you want, you can go through the YouTube and find the YouTube channel, which is under my name, Yuga Antalaktaru. And then after you can watch the things under the playlists, right? So anyhow, the only thing that you have to do is it's better you refer it. So it will be easier for you to do a small exam. Okay, are we clear with these people? Any questions regarding the website? Okay, right. Right, so I'm moving to the next lesson. Now the next lesson is about the fundamentals of a computer system. Now here you are going to learn about the features of the computers, classification of the computers, and what are the functions and devices of a computer system. Then you are going to learn about the basic components of a computer and the computer ports, as well as what is that we call as a network, right? Those are the things that you need to learn. So let's commence, right? People, let's have the main heading, fundamentals of a computer system. Okay, are we done? All right, moving forward. So in the very firstly, they have talked about what is a computer, and you know what it is actually, right? We don't need to introduce it. This is what you call computer because it is something we know, something that everyone knows, right? And we know that when an input is given, it is being processed and will give the outputs accordingly from a computer system. And they have mentioned why the computer has been an essential device in the life, right? So because of these factors, these are like key factors regarding for this reason. All right, so like the speed, the accuracy, the efficiency, and the versatility, and storing and retrieving. Due to these qualities, it has become a very important device that everyone needs, right? So it can do things, it can process things faster than us. It is accurate, right, when it is doing that. And since it is taking less amount of time, it is efficiency, it is efficient. And regarding the versatility, it's like using the computer in many different ways, or like many different tasks at the same time, right? So like you can hear to a song, you can listen to a song, and you can do whatever you are doing by using just a computer, right? So likewise, you can do many different things at the same time since it is handling things. And storing and retrieving, yeah, like without, like when it comes to the data and information, if we store those data information inside a computer, a very few things, or like a very few capacity that you are going to use. But if you are going to do it in manually, you may need a cupboard, you may need locks and all these things, and you will be taking some time to retrieve the data, right? So those problems can arise. Right. So yeah, as a commencement, it's better we write about these people, right? So I think you have done with the main heading. And as the next part, yeah, let's go like this. Some of the features computer can be described as follows. Right, take that as the first point. Then you can copy the entire table. But no, you don't need to reason. We'll have it in some other day, like not this particular topic, right? You just have this under the main topic, then we'll go for the subs. There is no any subtopic. You just write this one as the first point under the main topic. Then you draw the table. Let me know when you are done, people. Okay, one is done. How about others? No worries, no worries. Please on, keep it up. Doesn't matter. Okay, anyone who is still doing?
Sir, I'm still writing.
No worries, no worries. Do it. Write it down. So let me know when you are done. And people, you don't need to worry about the examination happening soon, because I checked the questionnaire. It is with the questions of the first and second lesson both. So you will be getting the paper after the second lesson. So don't worry. So you got time, the newcomers, so you can have it. And we are going to have an online examination, people. Like I'll let you know about the LMS with the time being, right? So yeah, keep it up, right? So you'll be getting an exam after the second lesson is done, right?
Sir, I finished writing.
Okay. Anyone who is still doing? Okay, so let's move forward. So the next thing is about the classification of computers. Now, there are many ways that we can classify the computers. Here, you have given two major ways. One way is like according to the physical size, right? The picture on my screen is not that clear. So I'll write it for yourself over here, right? So this is according to the physical size. That is what they have said here. And the other one is according to the technology, right? So, and there are many ways that we can classify this as well. Later, you will realize there are some more ways that we can classify a computer when you are doing the operating system lesson, right? But for the moment, we are just talking about two particular categories, which is according to the physical size. That means like how big the computer is, and according to the technology, like what kind of technology that the computer is using, right? So the first one is talking about classification according to the physical size. Now, the supercomputers. Now, this is a computer which spread over a particular floor of a building, right? Or in a very big particular area. And don't mix this up with the first generation computers, people, right? We are not talking about a first generation computer over here. Supercomputer is a very advanced computer, right? Like supercomputers are used inside an institution like NASA, where they are like using that to solve some big problems or like some big particular task, like these space related things, right? And some like the war related things, the battlefield kind of things, the strategies that need to be taken out for the battlefields, right? So those are some one big problems that they have to solve, right? So that is what the supercomputer is actually made for, to solve the complex mathematical problems, right? And due to that particular problem needs a very big processing power, it is huge compared to our particular personal computers that we are using, right? So remember, the supercomputers are big in size. So that is why we are having a category when we are categorizing those according to the physical size, right? So this is the biggest even today, right? And it has many different processors, many different hard disks, many different memories to do a very big performance, or to deliver a very big performance to the users, right? So it's good to remember, supercomputer is just solving a one big problem, one complex mathematical problems with the help of the components of it. And the next one, which is smaller than the supercomputers, is called the mainframe. Now the mainframe, even though it is smaller than the supercomputers, the function or the operation that is done by the mainframe is not that small, right? Mainframes cannot be used for the purpose of the supercomputers, right? Supercomputer is anyway better in performance, bigger in size. But when it comes to the mainframe is there to do millions of small transactions in simple terms, right? So like, if you think about the space programs, which is run by the NASA, as we discussed, it is a one big problem that has to be maintained with a supercomputer. And if you think about an e-commerce website like eBay, or like Daraz, or like Alibaba, right? Like it is a website which is having several millions of transactions per day, right? If you take eBay, sometimes it exceeds the millions as well, right? So, but if you think about a one particular transaction, it's a very small transaction that we are doing. We just choose a product, we pay for a product, all right? So the purchase is done. But those kind of small transactions happen in millions. So Mainframe is there to handle that kind of a situation. So Mainframe is there to process a very huge amount of transactions in a quicker manner. And still, it needs a very good processing powers, a very good storage, a very good connections, like those kind of things, right? So basically the internet is based on the mainframe computers, right? So that is what you call as the next category of the mainframe, of the computers, which we call mainframe computers, right? So here they have given you some pictures and we are going to watch some video regarding the supercomputer and the mainframe computer, all right? So yeah, before I move to the next topic, the mini computers, I'll show you what is there to deal with the supercomputer. All right, here we go. Hold on, I need to share the screen with sound, otherwise you won't be able to hear it. And there are some very interesting facts regarding this supercomputer and the mainframe computer, especially in the supercomputer video. So just look closely, people, all right?
As a developer, I realized ClickUp is an incredibly powerful engineering tool. I wish I knew sooner.
The race for the world's fastest supercomputer is on. China held the lead for the last 5 years, but the United States has surged ahead with Summit. It's a $200 million government-funded supercomputer built for Oak Ridge National Laboratory in partnership with IBM and NVIDIA. But what is a supercomputer? Today's supercomputers are comprised of thousands of connected processors, and their speed has grown exponentially over the past few decades. The first supercomputer, released in 1964, was called the CDC 6600. It used a single processor to achieve 3 million calculations per second. While that may sound impressive, it is tens of thousands of times slower than an iPhone.
If you have a smartphone, it is more powerful than the supercomputer that we had back in 1995 doing human genome.
Today, Summit consists of over 36,000 processors from IBM and NVIDIA that can perform 200 quadrillion calculations per second.
What a typical computer will do in 30 years, this machine will do in an hour.
Summit takes up 5,600 square feet of floor space and has nearly 200 miles of cable. It uses 4,000 gallons of water per minute to stay cool and consumes enough power to run 8,000 homes. But why do we need such fast computers?
It has tangible results in terms of how it helps society at large. It will translate into better appliances, better security systems, better delivery of power, more efficient homes. Every aspect of life, it'll change.
Supercomputers are used across all sectors, forecasting weather and climate trends, simulating nuclear tests, performing pharmaceutical research, and cracking encryption keys. Summit is the first supercomputer designed for artificial intelligence applications, and researchers plan to use Summit for AI projects that could identify genetic predispositions to cancer or opioid addiction. By surpassing China, the US has escalated the tech rivalry between the two countries.
There's no question the race is on. But this is not the space race. This is the race to knowledge.
But faster supercomputers are already on the horizon. The European Union, Japan, and China are all developing machines they say will outperform Summit. The next big frontier is exascale computing. That is, computers that can perform 1 billion times 1 billion calculations per second.
The use of this machine is only going to be limited by the imagination of the scientists who will have access to this machine.
All right. So, yeah. You had some fascinating facts down there, people. I think you have captured that thing. Let me take those things back to you. So the first fact is like they were saying like the very first supercomputer that was built is something very similar to the smartphone that we are using today, right? Or like it is slower than the smartphones that we are using today, right? So these were the performance of CDC 6600, which is the first ever supercomputer, all right? So it is done in 1964 and used only a single processor, all right? And it has the ability of doing 3 million calculations per second. Still, it's a pretty impressive fact, but it is slower than the smartphone that we are using today. All right, so like, see, it's not that little slower. It is tens of thousands times slower than an iPhone, right, which we are using today. All right, and yeah, now this, the Summit, the latest supercomputer. Actually, it's not that latest, people. This video is from 2018. All right, things can be largely changed within these 4 years, right? But still, Summit had 36,000 processors. We have only one processor inside our computer, but Summit had 36,000 processors. So comparatively, it is capable of 36,000 computers, or like it is capable of 36,000 times than our computer, right? And again, the next fact is this: 200 quadrillion calculations per second. We can't even imagine like how many zeros are there after the 200. Like it's going to be 16 or 17, yes, I remember. Right? It's a huge number, right? We can't even think about it, right? Like when if you take a normal computer that we are using today, it has the ability of processing like 4 billion number of instructions per second. That is why we are getting the processor speed by 4 gigahertz, 4.8 gigahertz, 2.2 gigahertz likewise, right? But this is 200 quadrillions, right? It's way more bigger than the personal computers. And the power consumption, right? Look at this. It was the most interesting fact. So it is big, like it is laid over 5,600 square feet of floor space. Now 5,600 square feet means, people, it's something bigger like your main hall or an auditorium, right? And 185 miles of cables, right? If you think about the kilometers, multiplied by 1.6, right? And 4,000 gallons per minute to stay cool, right? Like there are so many processors, so it generates a very big heat. So because of that, they are having an extra way of like an extra cooling system, or like a special cooling system, which consumes 4,000 gallons per minute, right? And look at the last fact. consume enough power to run 8,000 homes. And you can see like how big it is. Like 8,000 homes means, I don't know, like in Sri Lanka, it's kind of a major city, right? It is that huge, people. Right, so that's what we have to think about the supercomputers. And what about the mainframes? So you got two types of videos, right? First, I'll show you the technical part of the mainframes. And this has a lot of explanation, people. So I'm not going to go for the
a lot more than blinking lights.
Explanation, right? So the first part.
Hi, I'm Esmeralda Quintana. I'm a ZOS performance analyst here at the PCC site. I just want to show you one of the machines I work on. So come. So this is a Z14 double wide. All right. So I could probably live in this thing. At a glance, we'll get into it. This is power. We have behind this I/O. More power with the SASE up there, I/O, and our processors. So we're gonna move the SC out the way. So up here, this is our power supply. We have two batteries up here. Something to know about the batteries is, they're kind of small. They do a very specific job. If power goes out, we want to make sure that we complete transactions in flight, right? Because data integrity is incredibly important to us and you, hopefully. All right, so over here, you see this nest of I/O. These are all PCIe I/O cards. You can see that we have a ton. We have even more on the back. There's some over there too. And if you just look at the rat's nest that goes down and is fed into the bottom, these cards we have OSA, FICON, we even have ZDC for data compression. A lot of cards here doing a lot of jobs, moving a lot of data. Right. Now this side, as I promised, even more I/O cards. Like I said, more on the back. We have another battery pack over here. And up here is the SC. Now, if you look, we talk about all this I/O, right? Come here. We have a switch for the internal network. We have that much activity going on that we need this. It's incredibly complex. And while you're looking, take a peep at this thing, okay? So this is a light bar, right? So let's just say you're working on the frame, right? And you notice, I/O card is going down, or maybe you just want to upgrade one. Maybe you have a problem child CP, but you're working remote. What you're gonna do? You can actually talk to the SC and light this up. This will actually point an on-site technician in the right direction. This will route them to a specific location. Now, real quick. Oh, come here, it's right here. There's a light board for PCIe cards as well, right? So that allows you to just, very easily communicate where your technician needs to go. Now, I mentioned the SC. The SC does a lot more than blinking lights. So, an airplane, right? You ever see the cockpit? It's full of knobs, right? Like just bells and whistles everywhere. That's what the SC is at a glance. So you think about this huge frame, you can tell it's complex, right? You saw those wires, you see this amount of processor drawers. What the SC does, it's the buttons and knobs of the airplane, right? So let's just think about an LPAR. What do you need to set up for an LPAR? Number of processors, are they shared or dedicated? How much storage? I mean, certainly you would have the real estate for that amount of buttons necessary. I mean, this thing is huge, I could live in it, but you don't want to handle that, right? You don't want to deal with all those buttons. The SC allows you that level of control in both a GUI tool called the HMC, so as a command line interface. So right here, we have two of them, right? Just like two pilots on an airplane. Redundancy is incredibly important. The two SC servers are up here.
Yeah, that is a lot to take, people, a lot of technical terms, but I'll go through the things like this is what looks like a mainframe, right? And as I told you, it is there. Dinetra, when it comes to the Google kind of a service, it's kind of a supercomputers that they are using, right? Because it is a huge process that they are going through, right? They have their dedicated supercomputers as well, the mainframes as well. But when it comes to the Google, they are maintaining the both, right? Because the data processing part, the search in algorithms and all these things are one big task, right? So they really work with both the types. So here in the mainframe, what you can see over here is the controlling part, right? So through this, she can talk to the mainframe, like configure the mainframe, right? And I think you could see that she was pointing the things inside the mainframe, like, yeah, over here. Yeah, these are some the cards which she's using or which is helping to do the transaction and having the connection with the outer world. And they have their backups inside this as well, in case of a power failure or something, right? And they have a very good caretaking about the transaction that is happening for the moment, right? In case, excuse me, people, in case of a power failure, it is not good to lose all the transactions. Like if you think about if they are going to lose the transaction details in case of a power failure, it's going to cost them in a very big manner, right? Because like there are many different transactions happens per second in the world. So if they just lose that thing, they are going to lose in big, right? And you will be getting a much clearer idea using this. And this particular video.
What comes?
Yeah, now here, this particular video will clear the things, right? And his presentation is much better when it comes to understanding things. Just enjoy it. It is a little bit big, but it's not that long, but it's good to see. He gives a much better answer regarding the mainframe.
Comes to mind when you hear the words big iron, heavy construction, extreme laundry, my nickname in high school? Well, it turns out that big iron is none of those things and usually refers to mainframe computers, massive machines that typically live inside of large cabinets. Okay then, Linus, so you're talking about a supercomputer, right? Actually, no. Mainframes are defined a little differently. In our episode on supercomputers, which you can check out here, we discussed how they are great at number crunching to complete extremely complex tasks like weather forecasting, medical research, and cryptanalysis. But with mainframes, the focus is more on throughput and reliability. So what exactly does that mean? Well, compared to something like a supercomputer, mainframes have a lot more inputs and outputs, or I/O, because they're often deployed in situations where they aren't working on one massive complex problem, but rather they have to process tons of smaller, simpler transactions extremely quickly. In fact, even though there is a popular misconception that mainframes are relics of a bygone computing era, to process the up to millions of card swipes and account transfers that occurred daily, 96 out of the world's top 100 banks and 23 out of the top 25 US retailers currently run mainframes from IBM, who has been the dominant player in the industry for a very long time. Building one, though, isn't just a matter of installing a whack ton of Xeons in a box, plugging in lots of Ethernet cables, and calling it a day. Mainframes use special CPUs, many of which are much larger physically than even big desktop chips like 2011 socket CPUs from Intel, as well as additional processors called System Assistance Processors, or SAPs, that do almost nothing but move data around as quickly as possible, like glorified traffic controllers, rather than general-purpose number crunchers. And that's not all. On a modern mainframe, like the top-end IBM Z13, Each individual I/O card, of which there can be 160, has its own processing cores, up to 2 per channel on the dual channel cards, meaning you could have over 600 processor cores just for I/O, and that's not even counting the SAPs. Whoa. Part of the reason that modern mainframes are designed to support this much I/O is to ensure that they stay reliable. So many of the subsystems inside a mainframe, like a modern airliner, would have redundancies built in. This means they can be deployed in situations where 0 downtime is acceptable, such as the aforementioned credit card companies and retailers, as well as airline ticketing systems. In fact, a common mainframe operating system, IBM's proprietary ZTPF, was originally developed as transaction processing software for airlines. If you want to see it in action, pay close attention next time you board a flight, and you might just get a glimpse of the computer screen they're using to check you in. An old-school interface with green text indicates that it's probably a terminal connected to a mainframe. Just don't look too closely at it. So this high level of redundancy means that it's common for mainframes to be built in such a way where an administrator can slide out one of the drawers that houses components and simply start swapping them out. Whatever that drawer was working on is automatically transferred over to the rest of the mainframe, making it easy to make necessary hardware changes without any downtime. Which is a good thing too, because high-end mainframes can run tons of virtual servers at once, up to 8,000 in the case of the Z13, meaning that taking down the mainframe could result in a lot of transaction errors on Black Friday. But before you start thinking, gee, I should get myself a mainframe because I want to run Overwatch on like some kind of 50-monitor setup, mainframes and their operating systems aren't just absurdly expensive. A single mainframe can cost hundreds of thousands, if not millions of dollars. They also aren't designed to run games or for high-end floating point performance, which is important for rendering graphics.
Okay, so that's the story of the mainframes. What you have to understand from here is like, it is a technology that is using for the moment in the world, right? And he was telling this fact over here, like most of the banks and most of the supermalls, like Walmart, they were maintaining their own mainframes, right? And the dominant player, or like the one who is creating these things, is the IBM company, where he's the only company which is maintaining these things, right? And as it says, as we discussed, it is there to solve, or it is there to maintain many different number of small transactions which is going through, like which is happening inside an e-commerce website. Okay, people, did you got some particular clear picture regarding the mainframe and the supercomputers? Is that clear? Right.
Yes, sir.
Okay, great. So let's go through the things that we have to note down. So yeah, let's have the heading, classification of computers. And after the topic, you can draw this. All right, so this particular hierarchy. The word that is not very much clear to you, I have typed it for yourself over here, according to the physical size and according to the technology. Then after, let's visit to the notes. Right, Sanoshi, I'll go through that when the time comes to that point. All right. Are we done? Anyone who is still writing this? Okay, shall we move forward? Yeah, Rizwan, you can ask the question after the session, Puta. No worries. So get ready. And once we're done with the lesson, then we can go through that. Okay, so I'm moving forward. So have the subheading, classification according to the physical size. So under that, have the first type, supercomputers. Yeah, so we have to go through the entire paragraph, people. It has only the very important stuff regarding the supercomputers. So please copy it down. And people, it is a very kind reminder that we are starting the classes at 3:15 in the vacation. So have that in your mind. Right, so so from 3:15 to 4:45, we are going to have in the vacation period. Then after to the same time slots, 3:25 to 4:55. All right, one is done. How about the others? Right. Anyone who is still writing? Just raising your hands is enough, people. Okay, keep it up, people. Doesn't matter, doesn't matter. Okay, can we move forward? All right, so moving forward, the mainframe computers. So have the heading. Yeah, we have to go through it, people. And someone asked a question regarding the second line. Who did? Sanushi, it's you, right? Yes. Sanushi, the second sentence is explaining the, like we talked about, like mainframe is there to do a lot of transaction. So like when it is doing a lot of transaction means, like if you think about the eBay, if the eBay is having a mainframe computer, like many people around the world will do the transaction with that mainframe, right? Purchasing a good is a transaction with the mainframe. Doing a payment is a transaction with the mainframe. That is what he's saying. A number of users get connected to one computer using number of terminal, sharing, saving, and retrieving data, right? So it's the simple explanation. Is that clear, Sanushi? Right, great. So now once you are done with these people, you can disconnect from the session since it is 4:45, right? I will stay here until all you are leaving the session, right? So we'll talk about the other two, that like the microcomputer and the mini computer by next week, right? And be there at 3:15, everyone. But I'll see you on next week for the very same time. So when you are done, you can leave, right? I will be staying until every one of you leave the session, right? Thank you very much, everyone.